Okay, so let's first recall what we have learned last time. I think last time we were able to define what a group is, no? When you say a group, uh, we have two components, no? The first component is a non-empty set. The second component is a binary operation defined on the given set, uh, which has these three nice properties. No, the first property is that the operation is associative, and by associative we mean what? We mean that for every triple of elements A, B, C, and G, what do we have for associative property? Dapat ang A times the product of B times C must equal A times B, the product A times B multiplied with the element C. That's associative property. The second property is that the fact that there must be an identity element for G. An identity element is usually symbolized by the letter E. No? This element must be in E, and this element must have the following property. What is that property? What makes it the identity element? It is the identity element because for every A in G, no, when you multiply A with that identity element E, it gives you the same element A, whether you multiply it to the right or to the left of the identity. Okay. Last but not the least is the existence of inverse elements. The third group axioms. The third group axiom guarantees you that every element must have the respective inverses with respect to the binary operation. In symbols, that means for every element A in the group G, there must be another element, uh, say A prime in G, no? So that yung A prime will be called the inverse of A if and only if whenever you multiply it to the left or to the right of uh, A, you get the identity element. So that is what we mean when we say an inverse for the element A. So if these three conditions are satisfied, then we call the pair a group, no? But usually kapag sinabi nating group, we normally refer to the set. So for example, sinasabi ni Sir madalas, let G be a group. Pag narinig niyo let G be a group, it actually implies that there is a good binary operation defined in it. Na hindi pa pwedeng mabuhay ang group nang walang binary operation. Okay? Yeah. So, as you can tell from the definition, hindi required ang commutative property for an operation in a group, but then hindi naman din bawal. Just in case that the operation is commutative, we say that the group is, the term that we are using is, anong tawag natin sa group na may commutative na binary operation? Once again, anyone?
Abelian group.
Okay. So we call a group abelian if in addition the operation is commutative. So let's continue our discussion. And let's go back to the slide where we were. No? Okay. So last time we stopped with this exercise. In fact, we did number 1, but we haven't finished number 2 yet. Okay. So here G is defined to be the set of real numbers excluding -1. So we do not include -1 in the set. Now on G, or on this exclusion, we define the binary operation star as follows. X star y is x plus y plus xy. So in words, you can say that the star combines the sum and the product of two real numbers x and y. Parang pinagsasama niyo yung, ina-add niyo yung sum tsaka yung product nung dalawang real numbers na x and y. So that's what it does. For number 1, we did show that G is closed under star. If you can remember, ito yung huling slide na ginawa natin. Pinakita natin that if x and y are not negative 1, we were able to prove that x star y is also not negative 1. So, meaning to say, product of two elements in G remains inside G. Now, this closure property is important, no, to check before proving that actually this is a group. Kasi the closure property will guarantee you that star defined on G will be a binary operation. Now, let us now show that the group is an abelian group. May word na abelian, so siguro ang una kong i-check ay yung commutative property, no? So, for commutative property, susulat ko dito para may guide kayo kung ano yung ginagawa natin. So, gagawin ko, I will take two elements in G, let's say x and y. Okay? Dalawa lang, no? Kasi commutative property ang i-check natin. As you can see, if I evaluate x star y, I get x plus y plus xy. Because addition and multiplication are known commutative operations, no, in the real numbers, then we can rewrite this algebraic expression as y plus x plus yx, right? Now, the resulting expression is simply the product y times x. Do you agree? So therefore, we can conclude that star is a commutative binary operation. Right. So for associative property, ito yung unang group action. Kaya ko lang inuna yung commutative property kasi may word na abelian nga, no? Pero hindi naman kailangan una, pwedeng huli, no? Alright. So for associative property, we need to consider three arbitrary elements. So let's take x, y, and z. Okay. Natural na x, y, and z ang pipiliin natin. So first, I will compute the product x star y or z. Ito muna yung kukompute natin. That parenthesis, that pair of parentheses means that uunahin natin i-operate yung x times y. Bago natin yung product, i-times ulit sa z. So yung x star y will mean x plus y plus yz. And then this resulting real number will be starred with the element z. Now, how do we do this? Remember, star means we combine the sum and the product by adding. Okay, so if we add, this is the sum, and then we multiply. So algebraically, we just want to just simplify this expression. Ay, parang may mali. May mali ba? May mali nga. O, kita nyo? X plus y plus xy. Saan ba ako nakatingin? So that's xy. Oops. What happened? Okay. Pumalik lang. Sorry. xy. This is xy. Right? May mali si sir doon. Paki-check nyo mabuti. This is the corrected one. Okay, now, we just simplify this algebraic expression. As you can see, this is x plus y plus xy plus z plus xz plus yz plus xyz. So the resulting product has how many terms? It has 7 terms all in all, no? Now, when you look at the other product is now x times y star z, no? So in this case, we will multiply y times z first. Okay? So how do we multiply y times z? That's y plus z plus yz. Yan. And then, paano ginagawa yung x star y plus x star something? Ganun ulit. We simply add and then we multiply. And then we simplify as algebraic expression, as an algebraic expression. You see that this is x plus y plus z plus yz plus xy plus xz plus xyz. Okay. Now all we need to do is to check if the terms are identical. No? For example, my x, my y, my y, my xy, my xy, my z, my z, my xz, my xz, my yz, my yz, at my xyz. So as you can see, they are actually equal by the commutative property for addition. So therefore, x star y star z equals x star times the product y star z. Because x, y, and z are arbitrary elements, we can say that star is an associative binary operation. Is associative. Okay? Nasusundan nyo up to this point? Up to this point, nasundan ninyo? All right. Thank you for your reactions. Now, okay, yung pangatlong part, actually yung pangalawa ito sa group actions, we have to check that an identity element exists, no? What do you think is the identity element? Which one will actually play the role of E? Any guess? Which one will be the identity element in this set? What do you think? Any trials in your mind na, di ba sabi ko, gawin nyo na ito sa bahay para mabilis na tayo ngayon? Anong na-discover yung identity element?
0, sir.
0 rin, no? Just like yung identity element for multiplication. So, take E to be 0. As you can see, if you take an arbitrary x in G, then whether you do x star E, paano x star E? That's x plus E plus xe. But what is E? E is 0. So that's basically x. But remember, the operation is commutative. So ang x star E, pares lang yun sa E star x. No need to compute. So really, this is the identity element. Okay, it's part of G. All right. Last action, of course, but not the least. In fact, normally this will be the hardest part, but not always. So let me just clear the page. For the last part, we're going to check the existence of inverses. Yeah, existence of inverses. So yeah, so what do we do here? Here, we take an arbitrary element of the group, let's say x. Now, in our mind, what do we need to show? In our mind, we need to show that there exists an element x prime, no, in G, so that ang property ng x prime na yan is that yung x star x prime will be the identity 0. And of course, no need to check kasi commutative naman. Yung x prime times x dapat 0 rin, no? So that's what we need to show. We need to show that for this arbitrary x, there corresponds an element x prime in the group or in G where their product is the element 0. So where will you get that x prime? Ano kayang formula? Kapag si x ay element nandiyan, ano kayang formula for the inverse? Kasi halimbawa, ano yung sabihin ni sir ng formula? Halimbawa, kapag ang operation natin ngayon simpleng addition, no? If we're talking about addition, ang formula nyo sa inverse is just minus x na maglalagay ka lang ng minus sign sa unahan. Kung ang operation natin multiplication, if you can remember, ang formula natin sa inverse ay 1 over x. Kinukuha mo yung reciprocal. But for this type of operation, what do you think will be the general formula for the inverse if this is the case? Ayan, may nag-raise ng hand. Who would like to answer? Ayan, si Aaron. Aaron, do you have any idea?
Negative x over 1 plus x po.
Ang nakuha mong formula ay minus x over 1 plus x. Ganyan ba?
Opo.
Okay. Would you like to share how did you come up with this formula? Paano mo naisip ito?
Yung equation po na x plus y plus xy, in-equate ko lang sa 0 since yun po yung definition po ng ano.
Actually, that's correct. Na ang gagawin nyo, this is your working equation. So, basically, mag-scratch ka muna on the side. So, this is part of the challenge, no? Gagawa ka ng scratch sa gilid. Wala yung scratch mo, no? Ang iyong working equation will be x star x prime equals 0. That's very good, Aaron. Ito yung working equation mo. So, you will attempt to solve for x prime. Kasi that's what you wanted to know. Ano bang formula para sa x prime? Well, ang definition ng x star x prime is x plus x prime plus xx prime. Now, you're going to solve for x prime. So, i-isolate mo yung x prime sa isang side. That's minus x. Tapos, factor mo pa ganyan. Yan. Now, ito yung reason. Makikita nyo, nandito yung wisdom ng problem. Bakit natin ini-exclude yung negative 1 from the discussion? Why is that? Para pwede natin isolve yung x prime. Kapag kasi ang x ay hindi negative 1, yung 1 plus x will not be 0 and you will be allowed to divide. Kasi if x is allowed to be negative 1, ayan, you have to consider that case. Mawala ng inverse yung negative 1. Parang ganun yung idea. Parang yung 0, di ba? Yung kapag multiplication, yung 0, wala siyang inverse. Kaya ine-exclude natin siya to become a group. So, ang na-solve nyo dito does not prove anything. It's just, well, it's your candidate for the inverse. How do you show that inverse actually works? So, ganun yan. Take x prime to be minus x all over 1 plus x. Ang una nating ipapakita, bago natin ipakita na siya yung totoong inverse, is that you have to ensure first that x prime must remain in G. Kasi kung titignan niyo yung axiom, no, yung a prime dito sa third axiom must be an element of the same set. So, yun yung kailangan mong i-assure ng unang-una. So, first we need to assure that x prime is in G. In other words, we have to show that x prime is not negative 1. Okay? So, how do we show that x prime is not negative 1? How do we prove that x prime is not negative 1? Ayan, narinig niyo yung pinoprove natin. X prime is not negative 1. So, how are we supposed to prove that? Anong sabi ko sa inyo kapag ang pinoprove natin is not, has no, yung mga ganyan? Anong type of proof?
Use proof by contradiction.
Yes, very good. Proof by contradiction. So, we will suppose that x prime is what? Is negative 1. No? That is, ano yung sabihin ko na x prime is negative 1? Minus x over 1 plus x is negative 1. Anong mangyayari? Ang mangyayari ngayon, multiplying by 1 on negative 1 on both sides, ito yung mangyayari. Multiply ako ng 1 plus x on both sides, ito yung mangyayari. And then subtracting x on both sides, ano mangyayari? That's 0 equals 1. Of course, this is a contradiction. No? What did we prove now? Kung may contradiction, we now did prove that x prime essentially is an element of G. Now, last step is to prove that it's indeed the inverse. No? Tama? Finally, just check that x star x prime will be the identity. But what is x star x prime? This is x plus x prime plus x prime. Binura ko na yung scratch ha. Na supposedly it's not really part of the proof. So x plus, so you're going to simplify this weird expression in yung form yun sa inverse. There you have it. So, punta tayo dito. Tayo ha, continued. So, ano yung x star x prime? X star x prime will be, oh my gosh. So, LCD is 1 plus x, right? Okay, so let's do the algebra. That's x times 1 plus x minus x minus x squared. Is that perfect? Tama ba yan? Tingnan natin. Yeah, correct. Kasi ang lalabas dito upon simplifying is 0, which is the identity element. And of course, because the operation is commutative, you don't need to check the other portion. You can just write like so. Now, all of these things proved one thing, no? Ano yung prove na ito? That G star is, star pala na star, is an abelian group. So, ganon. Now, if you are asked to prove that this is an abelian group, ganyan nyo gagawin yan. Apat na steps yan kasi abelian ay commutative, associative, identity, and inverse. Okay? So at this point, we're now going to talk about more properties. Oh, wait. Did we skip something? No? Check ko lang ha kung meron tayong na-skip. No. Yeah. Okay, so we can continue. At this point, ang atin ang gagawin ay pag-uusapan natin ng yung mga properties ng mga groups that groups satisfy in general. So, generally, ano-ano yung mga katangian ng isang group? Kapag sinabi natin na si GI group, what are the properties that it enjoys? So, those are the things that we are going to talk about next in the next few slides. Right. The first property is what? The uniqueness of the identity element. This theorem or this result guarantees that in any group, you cannot have more than one identity element. Yeah, the axiom tells us that there is an identity element, but the axiom did not tell us that there is only one identity element, right? Because it can actually be proven from the axioms. Kumbaga doon sa definition, hindi na natin sinabi that there exists a unique identity element for G. We did not say that because yung uniqueness can actually be proven. No? How do we prove that a group can have does not have more than one identity element? So, ganito. So, let's say G star is a group in general. And ito, sinabi ko na sa inyo ito dati. Paano natin usually pinapakita ang uniqueness? Kasi meron naman yung fact that a group has already comes from the definition. Ang pinaprove na lang natin dito ay yung uniqueness. How do we guarantee uniqueness? Paano tayo nagpo-prove ng uniqueness? I think I mentioned something like this before. What is the standard method to prove that something is unique? Yan. Very good. Very good. So mga nag-PM, sabi nila, assume that there are two identity elements. Show that they are actually equal. Very good. That's actually what we're going to do here. Yan. So suppose natin that E1 and E2 are identity elements for G. Okay? So what do we have? E1, si E1 being the identity, because identity element siya, it means to say that A times E1 is A for any A in G. Correct? That's just the definition of E1 as an identity element. Also, because E2 is also an identity element, if I multiply it to the left of anything, let's say A, no, it also must equal A. Alright? Alright. Now, tingnan nyo to. Si A itong equations na to ay nag-hold kahit na sino ang ipalit natin kay A. Okay? Kasi for all yan. Kahit sinong ipalit natin kay A, mag-hold yung dalawang equations na yan. However, itong E1 at E2, they are themselves elements of of G. Sila ay mga nasa G. Correct, di ba? So, but they can take the place of A in these equations. In particular, kapag yung E1, nilagay ko dito sa second equation, yung A dito, if I replace that by E1, mali. Mali si sir. Ito pala yan. Sorry. If in the first equation, replace ko si A by E2, ito yung lalabas. E2 times E1 will be E2. Diba? Gawin mong E2 ito. Ito yun. Pinagpalit ko lang yung order. Yeah. And then what? Kung ito naman, dito naman sa second equation, i-replace mo si A ng E1, ito naman na mangyayari. E2 times E1 will be E1. So in the end, what happens is that E2 is just the same as E1. And that proves the uniqueness of the identity element. So that there should be a marker here. Sabihin, tapos na. Ito pala. Nandito pala yung marker. Napunta dito sa ilalim, yung box. So that proves the uniqueness of the identity element. So in a group, there is always a unique identity element. Kaya ngayon, pwede na nating sabihin the identity element. Ginagamit na natin yung word na the identity element instead of an identity. Kung mapapansin niyo ako before, I always use an identity element because kapag anong difference ng that tsaka nung an, kailan ginagamit yan sa math? Or in English in general, ginagamit din yan. Yung may difference yan, di ba? May subtle difference yan dalawa. Pag sinabing the identity element, sabihin yung identity element din is unique for G. Kapag ginamit yung an identity element, you don't know how many identity elements are there. You are just pertaining to an identity element. Possibly, there are more than one. But now, because we have a proof that the identity elements are unique in a group, no, we can now call it the identity element of G. Kaya nga sometimes, if G is a group, yung identity na yan, sinusulit din natin as E sub G. Especially kapag marami tayong groups na pinag-uusapan in one discussion. Let's say you have two groups to consider at a time. If you want to denote the identity of the group G, for example, sinusulat nyo E sub G to denote that this is the identity of G. Kung meron kang another group, let's say H, yung identity ni H sinusulat natin as EH. No? You will find that these notations are being used. Okay? What else? What else can we say about groups? No? Aside from the uniqueness of identity elements, actually, di ba? Every element in a group has an inverse. Yun yung nandoon sa axiom. If you look at the axiom, okay, especially the third one, it tells us that for every A, there is an A prime. Okay? Ganun yung axiom. Ang tanong, how many A prime in G will exist so that A prime is an inverse for A? The answer to that question is only one. Kasi according to the theorem, to the next theorem, theorem number 2, every element in a group must also have a unique inverse. Nag-iisa lang yung kapartner ng bawat isa. When I say kapartner, meaning yung inverse nila. Kaya, pwede nyong sabihin the inverse of A. No? Hindi ka mag-aalangan kung ilang inverse meron si A in a group. Naintindihan niyo ba yung halaga ng uniqueness? Do you understand why these things are important? Ha? Hello? Naintindihan niyo ba yung kahalagahan? Why this is an important idea? Bakit kailangan unique ang inverse? Diba? Para pwede mong gamitin the inverse of A. Hindi ka natatakot gamitin yung the. No? Okay. So let G be a group. Let's say that because the identity will play a role here, pangalanan natin yung identity as E. Okay? And let's take any element A of the group, an arbitrary one. Okay? We will prove that A has a unique inverse. Well, by the way, before I start, that A has an inverse, tapos na tayo dito sa has, na we are done. Ang ipoprove na lang natin dito again is the uniqueness part. Kumbaga, existence part ng inverse is guaranteed by the definition. So we will only prove here the uniqueness of inverses. So once again, how do we do that? We suppose that there are, let's say, A prime and A double prime in G. Let's say they are inverses for A. What do we have then? If A prime and A double prime are inverses of A by definition of inverses, dapat kapag si A multiply mo sa A prime, whether you do it from the left or from the right, pero ang gagamitin ko na lang yung from the right, no? Yung ito, sa kanan multiply yung inverse, ay E, which is the identity. Also, because A double prime is an inverse of A as well, kapag multiply ko rin yung A double prime sa A, whether from the left or from the right, it's the identity. Pero ang gagamitin ko na lang yung left multiplication, no? Yan. Pag multiply ko sa kaliwa yung A double prime kay A, ang lalabas identity rin. Because A prime, A double prime are inverses. Ano mangyayari ngayon? What will happen next? We wanted to prove what? What do we wanted to have in the end of the proof? What do we wanted to happen here? Very good. We wanted to have the equality A prime equals A double prime because that will prove uniqueness. Okay? So how do we have that? Ang gagawin ko, well, I will express A double prime as the A double prime times E. Why? Why can I do that? Because E is the identity. Definition niya ng identity. Ayan yung group axiom 2. By the way, pag sinabi kong G1, G2, G3, yan yung tatlong group axioms. Yung G1 associativity, G2 identity, G3 inverses. Okay? Right. Using the fact that E is the identity, A double prime can be expressed as A double prime times E. Correct? Now, I am going to use equation 3. So, I could replace E by A times A prime. Papalitan ko si E ng A times A prime. You see? Okay? Nakakasunod? Nasusundan ba? Okay. Ito na. This is the time when we use the axiom G1, which is the associative property. So, this pair of parentheses can be moved right here. Pwede ko siyang ilipat because of the associative property. Now, A double prime times A can be combined now, but according to equation number 4, A double prime times A is also the identity. And because E is the identity, anything multiplied to it, whether from the left or from the right, will give you the same thing. Because A prime was multiplied to E, the result is A prime. And in the end, what happens is that A double prime is just A prime. And therefore, that establishes the uniqueness of inverses. So nakita ninyo, no, how the group axioms, no, are used, paano sila nagtulong-tulong in order to conclude the uniqueness of an inverse. No? Nasundan ba yung argument ni Sir? Nasundan? Okay. So you see how these axioms are important in establishing theorems, no? Now, because of the uniqueness, ayan, naku, natakpan. Sorry. If the operation in a group G is not specified, ano ba sinabi ni Sir? Let G be a group, pero hindi ko sinabi kung ano operation, no? Yung unique na inverse ni A, yung sinasabing the inverse of A, is denoted by, usually, by A with a symbol -1 above it. So don't think that it's an exponent. It's just a notation. Okay? Yung A to the -1 refers to the inverse of A in an arbitrary group G. Kung walang operation na ini-specify. Halimbawa, kasi 'di ba yung A inverse na ganito, iba-ibang meaning niyan eh. Kapag ang operation natin ay multiplication of number, ganyan siya. Pero pag addition, ang inverse natin ganyan. Pero ang ating generic na notation for inverse is this. Gagamitin natin yung symbol na. Ba't ginamit natin yung A? Kasi nga, for every A, unique yung inverse niya. So yung inverse ni A, como unique siya for A, nag-iisa lang siya para kay A, ginagamit natin yung pangalan ni A, no? Yung namesake of A, for it, no? Yung inverse ni A will be denoted by A to the -1. Okay? Now, what are the nice consequences? Okay. Because unique ang inverse for every element, kung si A inverse ay inverse ni A, dapat si A, siya rin yung inverse ng A inverse. Tama ba yun? Why is that? Kasi tingnan nyo, A inverse being the inverse means if you multiply A with inverse, you get the identity. Right? Alright, tingnan nyo mabuti to. A inverse being the inverse of A means wherever you multiply it to A, whether from the right or from the left, you get the identity. As you can see, itong equation na to, pwede nyo ring tignan na parang kapag si A, minultiply nyo sa A inverse, kumbaga, i-change nyo yung, yung perspective. Ang gawin yung bida ngayon si A inverse. Kunwari, ang bida sa A inverse. Sinong inverse niya? Ang sagot si A. Kasi siya yung imumultiply mo kay A inverse para maging identity. Kaya, ang inverse ng A inverse is A. Okay? Maliwanag yung number 1, no? And this is just a corollary. Nangyari yan because of the uniqueness of inverses. Number 2 is somewhat important. Important that it has a name. Ang tawag dito ay yung shoes and socks property. I think I have explained this property before, no? Parang kapag kasi ikaw ay magsusuot ng sapatos na may medyas, syempre una yung sinasuot ay yung medyas, susundan nyo ng sapatos. If you want to remove both, ang una mong tatanggalin, syempre yung huli mong pinasok, which is your shoes. Tapos, huli mong huhubarin yung medyas. But in group, meron din tayong shoes. In groups in general, meron tayong tinatawag na shoes and socks property. This talks about the inverse of the product AB. Kasi remember, if A and B are elements of G, yung A times B, nasa G ulit yan. Ngayon, kung nasa G ulit ito, meron ulit siyang inverse kasi lahat ng nasa G ay may inverse. Ang tanong dito, ano yung inverse ng product na AB? Fortunately, meron tayong formula. The formula for the inverse of the product AB is B inverse times A inverse. Kung ano man daw yung inverse ni B times kung ano man yung inverse ni A. But in a reverse order. How do we prove this? To prove this, all you need to check is that this product, ito yung A times B, no? Ito yung B inverse times A inverse. I-multiply ko yan. Now, by associative property, I can associate these two first. Sila muna yung uunahin ko kasi magkatabi naman sila anyway, no? Right? Now, yung B times B inverse na yan will be the identity. And E being the identity, meaning it will just vanish in the product. Ang may iwanan, A times A inverse na lang, which is, again, the identity. Similarly, if you do the reverse order, kung ito naman ang multiply mo sa kaliwa, gagawin ko, for example, pag ito naman ang multiply mo sa kaliwa ng A times B, makikita nyo, itong dalawang mauna magiging E. No? Pag E niyan, itong dalawang maiwanan, mag-multiply ulit to E. And then the product is also E, as you can verify. Hindi nyo ito magagawa kung halimbawa ipipilit nyo yung formula nyo sa algebra na, halimbawa ito, in general, this is not true ha, in general, baka gawin nyo ito kasi ganito yung kinalakihan nyo sa algebra, di ba? In general, hindi yan totoo. Kasi for example, i-multiply ko yung A times B with A inverse times B inverse. Can you simplify that? In a group, we can only associate, but you cannot always apply commutative property. Kaya pwede nyo i-multiply ito, pero pag ginawa mo ito, dead end ka na. Wala nang mangyayari, di ba? Stop ka na. Hindi mo pwedeng pagpalitin ng order to, you cannot, because wala tayong assumption ng commutative property. Kaya nga, itong formula na to, actually ay nag-work, no? If and only if, what's the condition for G para ito yung mag-work, itong equation na ito? Kailangan yung A times B nag-i-equal sa B times A. Diba? It is the reason why in normal algebra, ang AB inverse ay A inverse, B inverse. Kasi in a normal algebra, ang AB pareha sa BA. Na? Right? May reason but ito nag-work in algebra. Kasi in algebra, yung product na AB will always be equal to BA. I mean, in the algebra of real numbers, that's what we mean. And because kapag multiply mo ito with AB from the left or from the right, lumalabas ay identity. That means to say, it is the inverse of A times B. So when they are multiplied together, you get the identity. That's the proof of the shoes and socks property. I just like to remark the following. Okay, remark. Wala kasi ito sa slides, but these are also important. Number one, in a group, G, ang A times B inverse ay equal sa A inverse times B inverse if and only if A times B equals B times A. Mangyayari lamang yung nais nyong mangyari if what? If the elements A and B commute with one another. Okay? And also in a group, if you have several elements in consideration, say the product of A1 up to AN, say there are n elements, you take the inverse. Ang una mong, what do you think is the formula for this? So you just take the inverse of each element, but you have to do it in the reversed order, no? AN inverse, an minus 1 inverse, and so on, hanggang ikaw ay makarating sa a1 inverse, pabalik. Parang ano to, generalized shoes and socks property. But this time, marami kang socks, hindi lang isa. Na posibleng tatlo yung medyas mo, and so on. Masagwa naman yung ano, no? Dalawa yung sapatos mong suot. Sabihin na natin dalawa yung medyas. Okay? So, marami kang layers na suot. For some reason, if you want to remove all of them, ang una mo tatanggalin yung huli mong sinuot. And in fact, this follows from the shoes and socks property by induction. Gagamit lang kayo ng simple na induction. Okay, may tanong ba kayo dito? You have questions so far? Okay. Let's continue. So, pang ilang property na ito? Uniqueness of identity, uniqueness of inverses, and then these are the consequences. The next one, it has something to do with the way we cancel things in algebra. Yung mga mahilig kayo mag-cancel, di ba? Yeah. The third result is what we call as the group cancellation law. Group cancellation laws, if you want. Kasi there are actually two, the LCL and the RCL, or the left cancellation law and the right cancellation law. So, ina-abbreviate yan by LCL and RCL. Anong sabi nito? If you are in a group G, let's say G is a group, and the elements A, B, and C are in G, whenever the product A times B equals the product A times C, what can be concluded? It can be concluded that B is equal to C. You can cancel the A's. Okay? On the left. Kaya left cancellation law because ang kina-cancel ay nasa left. On the other hand, the right cancellation law tells us that if the product A times C is equal to the product B times C, there's a common element C on the right of each side of the equation, then you can cancel that common element and conclude that A is equal to B. Okay? So these are the so-called left and right cancellation law. So I'm going to establish the LCL, and as an exercise, I want you to do the RCL because the proofs are very similar. Okay, ano LCL? Paano proof ng LCL? So here we get an assumption. Our assumption is that A times B is equal to A times C. We have to conclude that B is equal to C. How do we do that? I start with B. I express B as E times B, E being the identity. Okay? Right. Now, E, I'm going to re-express E as the product A inverse times A. Diba? I can write E as A inverse times A because A and A inverse are inverses. So their product is E. Now, so parang dito gumamit ako ng G2 action. Ito yung G3, third group action. And then gagamit ako ng G1 to use associative property. Mag-move yung parenthesis from here to here. There. Okay? Now, by a hypothesis, A times B is just A times C. So I can replace A times B with A times C, just like that. And then, again, using associative property, I have that. Now, A inverse times A is the identity times C is C. So in the end, what we have as a conclusion is that B is equal to C whenever A times B is equal to A times C. Nasundan nyo how the three group actions come hand in hand together to conclude the left cancellation law. Nakita nyo kung paano nagtulong-tulong yung G1, G2, at G3? Siyempre, kasama yung assumption na ito. I guess you can do the same for the right cancellation law, and I'm leaving that to you as an exercise. Maybe you can start somewhere. You start with A. Isipin nyo paano kayo makakarating kay B, just like what I did here. Sige, that's a very good exercise. Right? You know, may sinasabing importanteng corollary to, but I did not write in the slide. Ito, group cancellation laws. Lagay ko dito, rewritten. Isulat natin ulit. In a group G, okay, in a group G, anong in a group G? Number 1, LCL. Ang LCL sabi, if natin, if A times B is equal to A times C, then B is equal to C. If I take the contrapositive of this statement, paano yung contrapositive? So if you have this conditional statement, what is the contrapositive? How do you express the contrapositive of the statement if P then Q? What's the contrapositive?
Negation of Q, then
Yeah.
negation of P.
Not Q implies not P. Very good. And what do we know about these two statements in logic? They are equivalent. So mean to say, if one is true, the other is true. So, if I take the contrapositive of this, what do I get? I get the following. I get that whenever B is not C, then A times B is not A times C. Tama? And the right cancellation law can be restated as follows. If, what's that again? If A is not B, then A times C is not B times C. Anong sinasabi na itong dalawa? Why do I need to take the contrapositive? Now, why do we have to look at these laws this way or in this manner? May sinasabi ito eh. Especially when the group is finite. If G is finite, may implication ito. When you say G is finite, there are finitely many elements, okay? If G is finite, remember we can always present the group using a table or using the Cayley table. The LCL implies the following. Tingnan nyo to ha. If B is not C, so mean to say, kasi in this equation, hindi siya equation kasi not equal, you know? Nasa kanan yung B at saka C, nasa kaliwa yung A. So you can imagine na nandito yung B at yung C, hindi sila parehas. So they are in two different columns, okay? Now imagine niyo ito si A. Let me just use yellow na lang. Ito ngayon yung A times B. Ito ngayon yung A times C. Correct? Anong sinasabi nung left cancellation law if you interpret it? If you have two different columns, what do you have in a row? In a row, in two different columns, you have two different elements. Meaning to say, in any row, no two elements are repeated. That's LCL. If you have a group table, no, and you look at any row, kumuha ng dalawang elements dun na nasa magkaibang columns, ano sabi ng LCL? They cannot be the same. Kaya kung mapapansin nyo, among the group tables that we considered, none of the elements are being repeated. Ano ibig sabihin? Pag nakakita ka na dito ng 5, hindi ka na makakita ng 5 anywhere in the same row. Maaari magkaroon ng 5 in other rows, but not in the same row. Did you understand? O ano naman sinasabi ng RCL this time? I think you can make an interpretation for yourself. So, paano yung RCL ngayon? Wala namang nare-repeat in any column. Kasi this time, ang common ay C at nasa kanan. Let's say ito yung C. Ito yung A. Ito yung B. So, ito yung A times C. Ito yung B times C. Yung sinasabi na ito, if A is not B, then A times C is not B times C. So, I mean to say, in a given column, no two elements are repeated. That's the right cancellation law. That's why in any group table that we have considered, makikita nyo, walang elements ang nag-uulit in any row or in any column. For example, ito na lang, no, yung S3. This is the group S3. At ito yung parang symmetries ng equilateral triangle, if you can remember. No? Makikita nyo, wala kang makikitang row or any column where elements are being repeated. That's why sometimes in my class, in my class only, in my class, I usually refer to these properties as what? Ay, sorry, mali ito. Itong cancellation laws na to, I sometimes refer to this as the Sudoku property, no? I call this the Sudoku property kasi ito yung property ng mga Sudoku, no? In any row or in any column, walang element ang dapat na uulit. But formally, it is known as the group cancellation law. No? Ang kanyang formal na pangalan ay group cancellation law, but you can call it the Sudoku property because it has that Sudoku property. In any row, in any column, walang elements ang mag-repeat. Naintindihan nyo? Can I move on to the next property? Okay. The next property will take us back to where we started. Remember, where do we start in our discussion of a group? Remember, we started with the problem of solving a linear equation, right? And we did set the following goal. Sabi natin, we would like to create an axiomatic system where linear equations can be solved. And our attempt is to introduce the idea of a group, no? And hindi tayo nagkamali. In fact, this is our goal, no? In a group, linear equations will always have unique solutions. Ito yun. Sige, basahin muna natin. Ang nilagyan ko ng subtitle tong theorem na to, ang subtitle niya, Unique Solvability of Linear Equations. Pero alam niyo yung mas technical na pangalan niya, ang mas technical na pangalan niya is the quasi-group property or the quasi-group property. You may see some authors refer to this property as the quasi-group property. But I don't want to, I don't want to name things using complicated terms, no? So, kasi mas maliwanag na, ito yung sinasabi niya. In any group, linear equations can be solved uniquely. Ibig sabihin, has a unique solution. Ano ba yung linear equation ang sinasabi ni Sir? Ang sinasabi ni Sir, A times X is equal to B. O kaya, Y times A is equal to B. Nakikita niyo yung unknowns? Yung unknowns natin ay X. Dito ay Y. Kaya magkaiba itong dalawa kasi yung unang unknown nasa kanan, the second unknown, yung Y, ay nasa kaliwa. Remember, in a group, you have to distinguish left multiplication from right multiplication because we do not have an assumption of commutative property. That's why you always have to distinguish one from the other. In fact, you might sometimes also read the term pre-multiplication tsaka post-multiplication. Pag sinabing pre-multiplication or pre-multiply, imumultiply mo sa kaliwa. Pag post-multiplication, imumultiply mo sa kanan. Na? You may also read these terms in some books in algebra, especially with those which are non-abelian or non-commutative algebras. Okay? Ano sabi dito? In a group where A and B are in G, the equation AX equals B has a unique solution for X. Of course, in the same group G. Also, the equation Y times A is equal to B has a unique solution for Y. Okay? Also, the solutions must be in G. So just like before, I'm going to prove one of these two statements, and I will leave the other statement for you. No, kasi you will find that the proofs are very similar. Okay, so I'm going to prove one. For example, how do we show that this equation has a solution, and what is its how do we show uniqueness? First, yung ano muna, yung has, bago muna yung unique. Pag naririnig niyo to sa math, has a unique solution, has a unique blah blah blah, no? There are actually two things to prove. No, yung unang ipoprove niyo yung has na meron. Pangalawa, that it only has only one solution. Uniqueness. Naintindihan nyo? So, ganito yan. Ang insight is that, gawa ka ng scratch, sinosolve mo yung equation na ito. How do you solve that? Ang una mong ginagawa, di ba, kapag may ganyan kang equation, kagaya ng ginawa natin, mag-multiply ka ng inverse ni A sa kaliwa. Natural na ito yung maisip mo. So, gagamit ka ng associative property. So, maging identity yan. And eventually, you were able to solve for the value of x. Ngayon, yung nakuha yung value ng x na yan, no? Anong tawag dyan? Yan ay candidate. Yan ay kandidato for a solution. This is not a proof that it is the solution. Paano mo mapaprove na siya ay solution? Kailangan mailagay mo siya dun sa equation na to and check that the equality actually holds. Kaya kapag kayo yung nagsasolve sa algebra, let's say, solve for 2 plus x equals 5. Yung ginagawa nyong ganito, therefore x is equal to 3. Yung ginagawa nyong ganyan, it's actually finding for a candidate. Ano yung proof na siya yung solution talaga? What is your proof that is indeed a solution? Ang tawag nyo doon dotted check, di ba? Ang tawag nyo dyan dotted check. Nilalagay nyo yung 3 sa x, no? Sinasolve nyo yung 2 plus x, 2 plus 3 equals 5. So that checks that your candidate is indeed a solution. And that's what we're going to do. Kaya ko lang naman pinapakita itong scratch just to give you an insight kasi baka bigla na lang akong magulat. Wala sir, ba't bigla ka na lang may formula kay X? Paano mo naisip yon? Ito yun. Naintindihan nyo? So halimbawa, ayan, proof of existence muna. Ganito. Since A and B are given elements in the group, first of all, sure muna tayo na merong inverse si A. Yung A inverse nasa G. And by the closure property in a group, dapat yung A times B ay nasa G. Correct? So I can take that as my X kasi sure ako na nasa G yan. Remember, the solution must be in G. Kasi baka bigla kayong magtaka, paano mo naisip sa yung A inverse times B? The truth is, ginawa ko na siya beforehand. Did you understand? Pinapakita ko sa inyo insight kung paano naiisip yung mga proofs. Okay. We will show that this X will actually work. Yan. Paano? Compute nyo A times X. You will get A times A inverse times B. Use associative property. G3. That's E, and then finally G2, and that gives you a B. Therefore, AX is equal to B. What does this prove? This proves that this is a solution. Okay? But how do we prove that it is the only solution? So for the uniqueness, what do? We again suppose that there are two solutions, x1 and x2. So if x1 and x2 are solutions to this equation, what do we have? It is true that a times x1 is b, and at the same time, a times x2 is equal to b. But then, these two products are both equal to b. So therefore, they are equal. Okay. What can be said? Ayan na. Sige nga, anong karugtong na ito? Dugtungan nyo. Now, a times x1 equals a times x2. Okay, can you continue? Anong gagamitin natin? Very good. Gagamitan natin yan ng LCL o yung tinatawag nating left cancellation law. Because the left cancellation law has already been established, you can use that as a fact. Kanya? By the left cancellation law, you can cancel the A because it's on the same side of the equation. Tandaan nyo, you can only cancel kung parehas na sa left or parehas na sa right. Pero kapag ganito, nakalimutan ko sabihin ito kanina, huwag nyung gagawin to ha. Diba meron kang A times B, tas meron kang C times A. This does not imply B is equal to C ha. Hindi yan nag-follow. Makakancel nyo lang only when A is on the same side. Left kung left, right kung right. Hindi kagaya nito nasa mixed. Sa kaliwa, nasa kaliwa si A, sa kanan, nasa kanan si A. So you cannot do cancellation. Wala tayong conclusion. Okay? So by the left cancellation law, it follows that x1 is equal to x2. Therefore, any two solutions are actually equal. That's what we proved here. Because we have found one solution and any two solutions will be equal, what's the conclusion? Tapos na. This equation will always have a unique solution. Binigyan kayo ng formula para sa unique solution. Okay, di ba pinigyan ka ng formula para sa unique solution dito ang xi, A inverse times B. So palagay nyo sa number 2, what will be the formula for the solution? What will be the formula for the solution y, for y in equation 2? What do you think is the formula for y? Sige, I am waiting. You can put it in the chat box or you can just speak on the mic if you want. What will be the formula for y in number 2 if you do the same thing?
B star inverse of A.
B star inverse of A. Correct. That's correct. Kasi kapag ang y pinalitan nyo ng B star, B times A inverse, magka-cancel yung dalawang A, may iwanan ay B. Very good. Tandaan nyo yung mga formulas na ta because this will be handy whenever you have a linear equation just like this equations. Okay? O diba? Have we achieved our goal? Na-achieve ba natin yung goal na sinet natin noong unang slide? Ano yung goal natin? To create an abstract setting where where linear equations can be solved. Did we achieve that? Yes. Ginamit natin ay yung idea ng group. So basically speaking, when we talk about groups in algebra, mukha na ba talagang algebra yung pinag-uusapan natin? Unlike before, no? Yung start ng ating mukha bang algebra na to? Di ba mukha ng algebra kasi nagsosolve na tayo ng equation? Remember, the main business of algebra is to solve equations. Hanggang kayo ay matapos sa abstract algebra, mapapansin ninyo ang common theme or ang unifying theme is to solve and solve and solve for algebraic equations. Kaya pagdating nyo ng abstract algebra to polynomial equations lang sinasolve ninyo. Hindi lang basta linear. Okay? Alright, so I have here an exercise. Naalala niyo yung group na ito? Yan, yung group na G, whose elements are those real numbers excluding -1. The operation is quite weird. X star y is x plus y plus xy. I want you to solve for x in this equation. Sige nga. What is x in the following equation? Well, gagawin ko na kasi maubos yung time natin. I have to discuss something before 11 a.m. So, for the solution, wait, solution, all right. Remember, in G, anong formula natin sa inverse? Should I use this? Sige na nga. Ang formula ay minus x over, what is that again? 1 plus x? 1 minus x. 1 plus x? Yeah. Naalala nyo to? Na-establish natin to kanina. Huwag nyo kakalimutan yan. Why do I have to recall that? Because remember, whenever we solve for linear equations, we normally seek inverses of elements. That's why you have to recall. Ano nga bang formula sa inverse, sa system na ito? Sa group na ito, anong ibig sabihin ng inverse? Sa group na ito, anong ibig sabihin ng inverse? You have to recall that every time you're solving equations. So, for this, ang gagawin ko muna, para mapasimple yung equation, I will let y be 1 star x first. Para yung 1 star x star 3 equals 23 will be written as y star 3 equals 23. Ganyan. Diba? Alright. Now, I have y star 3 equals 23. So, how do I solve for y? Sabi nyo kanina, ang y kapag ganyan ay 23 times 3 inverse. Yung inverse ni 3 sa kanan, minamultiply. Ang reason for that, para mawala itong 3 sa kanan. Nakuha niya. Parang algebra lang naman ito. Huwag kayong matakot. Now, ano ngayon yung 3 inverse? Ang 3 inverse ay negative 3. Ay, ang format, hindi pala ganun. Star pala natin ay mukha talagang star. Negative 3 over 1 plus 3, that's negative 3/4. Imagine mo, no? Sa algebra na to, ang inverse ay, ng 3 ay negative 3/4. Hindi nyo makikita sa ibang subject yan. Dito lang yan. Okay? Huwag nyo gagawin yan sa ibang lugar. Okay? Now, all you have to do is to simplify this. Ano ba meaning ng star? That's 23 plus negative 3/4 plus 23 times negative 3/4. Oh my gosh. I don't think I like doing this. Sige na nga. Okay, 4. 23 times 4, that's 80, 12, 92. Minus 3. 23 times 3, that's, oh my gosh, 69. Tama ba si sir? Tama ba si sir?
Yes,
Now,
sir.
what's 92 minus 69? Ay, kapag ganito na, ayan na, ito na ngayon ako sa math. Yung mga may ganito na. So, anong value ng y? Oh my gosh. 5 ba? Is that a 5? Saktong 5? Okay, 5. Oh, sabi niyo 5 eh. Move ko lang to konti para magkasya yung susunod na line. Okay. Now, what do we have? Y is 5, therefore 1 star x is equal to 5. Isosolve nyo naman yung 1 star x is equal to 5. Ano ngang formula for x kapag ganyan? Ang formula naman, 1 inverse times 5. Yung inverse nasa kaliwa kasi yung 1 nasa kaliwa ng x. Because you have to remove the 1 on the left. No, that's the idea. Now, what's 1 inverse? 1 inverse is negative 1 half. Kasi ang formula natin ay ito. Don't forget, ang inverse ng 1 ay negative 1 half this time. Star 5. So, negative 1 half plus 5 plus negative 1 half times 5. Alright. So, how do we... Ayan na. Last na to. X is what? So, that's all over 2. Negative 1 plus 10 minus 5. Oh, x is 2. Tama ba si Sir? X is 2? Did I get it correct? Tama ba ang computation ko? X is 2? Yeah. If my computations were right, the solution, the unique solution, in fact, is x is equal to 2. You can make a check na pwede nyong checkan. Paano i-check? Paano i-check kung tama yung sagot? O di, checkan nyo yan. Check. Charot. Hindi. Ang sabihin ko ng check, ilagay nyo dito yung 2. Subukan nyo ilagay yung 2 dito in place of x. And then, check if the left-hand side reduces to 23. Okay? All right. Okay, another definition. Another day, another definition. Okay. Here, you have two different groups. Meron tayong groups na G star tsaka H triangle. Kaya lang naman yan, ganyan yung mga symbols. Sabihin lang yan, meron kang dalawang groups that have possibly really different operations. Posible na yung mga operations nila ay magkaiba at magkaibang sets ito. Na yun lang naman ang ibig sabihin yan. Okay? Alright. So, i-define ko ngayon yung symbol na ito. Pag nakita nyo ito, pag nakita nyo yan, ha? Ang laman nito, parang Cartesian product, yung G cross H, no? Pero we have a special notation in abstract algebra o in group theory. Pag nakita nyo ito, ang laman yan mga ordered pairs, G, H, where G is in G, H is in H. Okay? Ang gusto kasing mangyari dito ganito. Pag meron akong dalawang groups, paano ko gagawa ng bagong group out of them? Parang gusto kong gumawa ng bagong group gamit yung dalawang alam ko na group. Kasi ang totoo nito, gusto kong paramihin yung aking mga examples ng groups. Kasi meron ako maraming alam na groups, di ba? How can I make more examples? By doing the following. You can take the Cartesian product, pero syempre, hindi ito magiging group kung walang operation. Okay? Paano kung magmamultiply ngayon dito? Ang laman nito, mga ordered pairs na ganito ang itsura. How should I define this product para maging group? Ang sagot, ganito. Dahil yung mga first elements ay nanggagaling naman sa G, i-combine ko sila gamit yung operation ng G. At yung mga second elements, may mali dito. Oh. Mali ito. Shit. Sorry. This is very wrong. Ang magko-combine dapat ay G1 star G2, comma. Ang magko-combine yung dalawang H, triangle H. Dahil yung second elements mo ay nanggagaling sa capital H, ang gagamitin kong operation ay yung kay H. Okay? Ang tawag natin dito sa group na mabubuo natin, in fact, group siya talaga. No? Hindi, huwag na tayo magpaligoy-ligoy. Ang mabubuo natin ay bagong group at yung bagong group na yan, na ang laman ay mga ordered pairs. Okay? Ang tawag dyan ay yung external direct product of G and H. Okay? Haba yung pangalan, no? External direct product. Bakit, sir? Meron bang internal direct product? Yes. But we will be talking about that later. Not now. Kumbaga, tinuturuan ko kayo dito gumawa ng panibagong group gamit ang dalawang groups na alam nyo na. You can form the Cartesian product, and on the ordered pairs, i-define mo yung operations in this manner, you will form a group. Now, in this group, ano yung magiging itsura ng identity mo? Ano yung identity mo? Ano yung identity ng external direct product? Ang identity element dito will be the pair consisting of the identities from each of the groups, given groups, yung EG, EH. Natural yan, no? Kasi hiniram mo lang naman yung operation ng G tsaka ng H. At kapag meron akong G, H, how do I get the inverse? Well, that's G inverse, H inverse. Yung G inverse na ito, kukunin mo gamit yung unang operation sa G, no? At yung H inverse na to with respect to the operation in H. Nakuha ninyo? Nakuha ninyo kung paano kumuha ng external direct product? Ha? Okay. Alright. So, bibigyan ako ng example. Halimbawa, nakakita kayo ng ganito sa abstract algebra. Let G be Z2 direct sum, a direct product, Z3. Okay? Ano yung sabihin ng Z2 plus Z3 na ganyan? Ang laman yan, ang laman ng Z2 external direct product Z3 ay mga ordered pairs lang naman. Yung unang elements nang gagaling sa Z2 which has 0 and 1 only. Ang Z3, tatlong laman, 0, 1, and 2. Okay? So yung unang element, 0, i-prepare ko siya sa tatlo. Bakit tatlo? Tatlo yung elements ng Z3. Tapos yung pangalawang element na 1, i-prepare ko siya sa what? Sa tatlo rin, sa 1, 0, 1, 2 rin. Ito yung 0, 1, 2 ng Z sub 3. Ito yung 0, 1, 2 ng Z sub 3. Gets nyo? Bakit merong 6 na laman? Gets nyo ito? Gets nyo ha? Ang Z sub 2 kasi 0 at 1 lang ang laman. Pero ang Z sub 3 tatlong laman, 0, 1, 2, 0, 1, 2. So these are the possible pairings. Now, in this group, paano ba nag-a-add? Paano ba nag-multiply? Halimbawa, no? In-add ko kunwari, 1, 1 plus 2, 3. What do I mean by this? Ay, wala palang 2, 3, sorry. 1, 1, and 1, 2. Anong ibig sabihin ko niyan, for example? Ay, hindi pala add, multiply. Ano ba yung notation natin? Add dot lang. O, sige. Paano may co-combine yan? Dalawa. Ang gagawin mo, gagamitin mo yung operation sa Z sub 2 tsaka sa Z sub 3. Now, take note, itong addition na ito is addition modulo 2. Pero ito ay addition modulo 3. Although I'm using the same notation, no? But take note that, what? They come from two different groups, so they have two different meanings. Ang 1 plus 1 sa Z sub 2 ay 0, whereas ang 1 plus 2 sa Z sub 3 is also 0, which is the identity. Diba? Ito yung identity. Ano natuklasan natin? Kung ang product nila ay identity, that means to say na ang inverse ni 1, 1 ay actually si 1, 2. Diba? Ang inverse ni 1, 2 is also, of course, 1, 1. Diba? Sige nga, sabi dito, kunin daw natin yung inverse ng lahat eh. Alam ba yung inverse na ito? Itself, no? Kasi yan lang ang i-add mo sa 0, 0 para mag 0, 0. How about the inverse of 0, 1? Sige nga, can you tell me what will be the inverse of 0, 1? ang gagawin nyo lang, inverse nung una sa z sub 2, which is 0, inverse ng 1 sa z sub 3, may formula tayo ng inverses for z sub n, di ba? Yes. 3 minus 1, the answer is 2. Inverse of 0, 2, of course, 0, 1. Inverse ng 1, 0, that's 1, 0 as well. Tapos nagawa na natin yung inverse na itong dalawa. And I think we are done. Okay? Yan yung meaning natin ng mga inverses sa Z2 plus Z3. Alam niyo saan ginagamit to? Ginagamit to in particular sa computer science. Halimbawa, pag ginawa niyo yung Z2 plus Z2, ano laman nito? 4 lang. Ito yung 0, 0. In particular sa computer science, ang ginagamit lang Z sub 2. Pag math majors, kanya natin sinusulat yan. Okay? Pero kapag ikaw ay comsci major, hindi mo sinusulat ng ganyan yan. The way comsci students write these things are as follows. 0, 0, 0, 1. Tamad yung mga yun eh. In fact, convenient talaga yan. Kaya halimbawa, pag nakakita kayo ng Z2 plus Z2 plus Z2, no? Paano pag tatlo na yan? Triples na tayo ngayon. So, para mga binary strings na ito of length 3, ito yung 0, 0, 0, 0, 0, 1. Did you understand me? Yun lang naman yun. 0, 1, 0, 0, 1, 1. What else? 1, 0, ay. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Walo yan lahat. Pag ikaw ay math major, nilalagyan natin ng parenthesis as comma, comma, comma. No? Pero pag sa computer science na yan, they don't normally write that using parentheses and commas. Right? They just write the elements as strings of objects. No? Kaya kapag gusto mo ng binary strings of length 35, o di may 35 copies ka ng Z sub 2. Sa Z sub 2 kasi ang 1 plus 1, 0, di ba? Yeah. So, somehow the mathematics behind computer science is basically group theory. Kung mapapansin nyo, sa computer science, meron silang subject na parang abstract algebra ang dating, yung automata theory. And it's really just abstract algebra written in another language, but it's basically just abstract algebra. Kung mapapansin nyo. Kaya one applications of abstract algebra is communication theory and of course computer science. Kung ita-trace back nyo ang history ng computers, mathematics lang naman talaga yan. It is basically yung mga machines na-develop ni Alan Turing because of the decidability or undecidability of solving a particular problem. Parang ganon. Basta, mapapalayo tayo. So, later ko na yung ikwento. Okay? So, let me tell you something about the multiplicative group notation. Kapag karaniwan, ang group may ka-pair na operation, no? Kaya lang kasi nakakapagod isulat yung, di ba? Nakakapagod isulat, let G star be a group. Sometimes, pag tinatama si sir, lalo na kung di naman mahalaga kung ano yung particular na operation, I sometimes just write let G be a group. Kapag nakakita kayo ng ganito na phrase, walang binanggit na operation si sir, it doesn't mean na walang operation si G. The truth is, meron niyang ka-pair na operation but it doesn't have to be defined. Naintindihan niyo? Kumbaga, we're talking about groups in general. Okay. When we're speaking of groups in general, by default, we are going to use the multiplicative group notation. And let me introduce this notation for you. Using the multiplicative group notation, pag walang operation na binigay for G, Okay? We will write the product of A and B simply by AB. Pinagdidikit na lang natin. Okay? But ginamit yung word na multiplicative kasi parang ginagamit natin yung multiplication na sa algebra. Di ba sa algebra naman na pambata rin, instead of writing 8x times y, sinusulit nyo lang as xy. Parang gina-juxtapose ang tawag dyan. Pinagdidikit. Okay, gina-juxtapose lang yung A and B together to express the product AB. Yung identity element of G denoted by E, no? In extreme cases, no, in some books in abstract algebra, you will find that some authors use the symbol 1 for the identity element. But that doesn't mean na tinutukoy niya yung number na 1. Yung numeral na 1 ay ginagamit ng ibang authors to refer to the identity element. Pero ako, para hindi niyo ma-confuse na siya yung number na 1, na hindi talaga yung number na 1 na represent ng symbol na 1, ang ginagamit ko pa rin ay E. Okay? Si Sir, ang gagamitin ay E, generally for identity. And for inverses, I will still use A inverse. Pero ito, take note, itong mga notations na ito ay very limited only for groups which are multiplicative in nature. Pero halimbawa kapag ang group natin, kunwari Z sub 5 under addition, weird gamitin ng multiplicative notation dito kasi first of all, ito ay additive. Intindihan nyo? Pag si A and B nasa Z sub 5, hindi natin isusulat yung sum ng AB. Susulat pa rin natin ng A plus B para hindi tayo ma-confuse. Okay? Malalaman yan from the context. Okay? Tsaka yung inverse, hindi natin isusulat ng A to the minus 1. Rather, we will use minus A kung additive. Okay? Right. Ito na. Meron tayong tinatawag na exponent sa algebra. Di ba? Meron din tayong exponents sa group theory. Pag nakakita kayo ng a to the power of n, where n is a positive integer, ang ibig sabihin lang yan ay repeatedly just multiply a to itself n times. Just like before. Okay? Yun lang ang ibig sabihin ng a to the n. Why can I do this? Because multiplication is associative. If not because of the associative property, hindi nyo ma-define yung a cube, a to the fourth, for example. Kasi ang a to the fourth, di ba? Ano to? A squared. Sinong unahin mo? Ito ba o ito? Kung hindi associative ang multiplication, magkakaproblema kayo. That might not mean the same thing. Because of associative property, nagiging legal gumamit ng exponents. Isa yan sa mga benepisyo ng associative property. If your algebraic system follows or subscribes to the associative property, pwede kayong mag-define ng exponents. Ano pa? Kapag ang exponent ay 0, we just define a to the 0 to be whichever is the identity element. Just like in the normal number, di ba kapag ikaw ay nasa R star, under multiplication, hindi kasama yung 0 sa usapan ha. Ang a to the 0 ay 1 kasi 1 yung identity element. Yun yung ating definition. Paano sir kapag negative yung exponent? Ano ba a to the negative 3? Anong meaning yan? Ang meaning lang yan ay, yung A inverse, uulitin mo ng 3 beses. Okay? Yan ang meaning niyan. Meron kasing meaning yung A inverse in a group, di ba? So, ulitin mo lang siya ng 3 beses. Yun yung ibig sabihin natin ng A to the minus 3. Did you understand these notations? Naintindihan niyo yung notations na ito? Nagmumukha na tayong algebra, no? Unti-unti na tayo nagmumukhang algebra. Para lang tayo nag-algebra one more time, but then in a more rigorous manner. Halimbawa, you have a group G, simplify the following, let's say a cubed times a squared. Paano yan? Para ulit kayong bata, no? Ang isabihin lang yan, 3a dalawang A. Pag tinanggal mo yung parenthesis because of associative property, A to the fifth lang yan. Kasi meron kang 5 A all in all. Ito naman, 3 A, dalawang A inverse. Yun ang isabihin ng A to the minus 2. Magka-cancel to, may iwanan isang A. Diba? Paano pag A to the negative 2 times A squared? Ang ibig sabihin yan, dalawang A inverse, dalawang A. Magka-cancel to, magka-cancel. Ay, wala natira. Meron. Identity. Okay ba tayo? Okay ba tayo dito? Yeah? It seems like merong pattern, no? Yeah. You are correct about that. How about in this group? For example, ito na, binigay ko na sa inyo yung group table. I call this the Cayley table of the group S3. Para hindi nyo na kailangang i-multiply gamit yung mga definitions ng 6 na element. Binigay ko na yung table. Calculate the following. Ano yung sabihin ng rho 2 squared mu 1 cube? Oh my gosh. Ano yung sabihin ng rho 2 squared? Rho 2 squared is rho 2 times rho 2. So, i-multiply mo, that's rho 1, di ba? Mu 1 cube is mu 1 times mu 1. So, ID. Okay? If ID gets multiplied to mu1 one more time, of course, the answer is mu1. Okay? What's rho 1 times mu1? The answer is mu3. Okay? Did you understand? Hindi naman mahirap to no? Ano naman meaning nito yung square nasa labas ng parenthesis? Ang ibig sabihin niyan, guys, uunahin nyo munang i-multiply yung nasa loob bago nyo i-square. So, yung rho 1 mu1 ay mu3, di ba? Di ba? Right? O, tapos tsaka mo i-square. Ang mu3 squared, mu3 ay identity. Okay? How about rho 1 squared times mu1 squared? Ito naman, rho 1 times rho 1. Oh, rho 2. Rho 2 times mu1 squared. Oops, identity. Rho 2 times mu1. What's the answer? Mu2. Tama ba si sir? Did I do it correctly? Sana ganyan lang kadali palagi, no? May napansin kayo? No? Napansin niyo ba to? Hindi parehas na? Yes. In a group, ang AB to the power of n is not all the time equal to A to the n, B to the n. Hindi totoo yung anong tawag niyo dyan? Law of exponents nyo dati sa algebrang pangbata. But you will see later that it will be true as long as A and B commute with one another. Yeah. In fact, all of them are stated in the following theorem, which is called as the laws of exponents. Alam niyo naman ito bakit, na? And I don't think I need to explain much of this. But we have n copies of A, m copies of A, therefore those are n plus m copies of A. Ang inverse ng A to the n is n copies of A inverse. Diba? Ang isabi nito, para kasi ini-inverse mo yung n copies ng shoes and socks. Uno mo lang inverse ng bawat isa, but in a reverse order. But order here doesn't matter kasi pare-parehas A yan. Okay, that's A inverse to the n. So therefore, that's A to the minus n by definition. Okay? If you have m copies of n copies of A, all in all, that's n times m copies of A. I don't think I need to explain all of this because these are intuitive, no? Yung number 4 lang ang gusto kong linawin dito. Yung n power ng AB is not necessarily the same as A to the n, B to the n. No? Nangyayari lamang yung equation na yan only when AB equals BA. Halimbawa kasi, pag meron kang AB squared, ang ibig sabihin talaga na AB quantity squared, ang ibig sabihin talaga niyan, dalawang beses mong uulitin sa AB. Whereas ang A squared, B squared, AA, BB. Parehas ba yan sa group? No? In groups, these two expressions are not necessarily the same because AB is not necessarily the same as BA. Kaya mag-iingat kayo ha. Certain rules, especially yung mga ginagamitan ng commutative property, no longer necessarily holds. Unless pag sinabi ni Sir, let G be an abelian group. Ayan, maluwag yan. Kahit na anong properties ang gamitin ninyo, nag-hold almost, no? Tingnan nyo, mag-i-equal lamang ito, left cancellation law, right cancellation law, only when BA is equal to AB. And inductively, you can prove this to be true for any n. May tanong tayo sa laws of exponents. Okay. Just for fun, consider the function a of x, 1 minus 1 over x, for all x different from 0 and 1. Kaya ko lang naman in-exclude yung 0 at 1 para maging bijective ito. Bijection yan. Nakita nyo na dati yung 6 na functions. Isa to dun sa 6 na functions. Calculate a cube of x where a cube is a, circle a, circle a. So pag sinabing a cube of x, tatlong compositions ng a yan. No? So halimbawa, ang a squared of x actually means a of x. Kaya ito yung a of 1 minus 1 over x. Apply mo ulit 1 minus 1 over 1 minus 1 over x. Ganyan yan. So, ito ay 1 minus, multiply ka ng x over x. Ganyan. Mangyari x over x minus 1. Tapos, x minus 1, x minus 1 minus x. Or you can write 1 over 1 minus x. That's a squared of x. Ano naman yung a cube of x? Basically, this is a of a squared of x. Diba? So that's a of 1 over 1 minus x. Ano lalabas? 1 minus 1 over 1 minus x. Ito kasi yung formula sa a. Lalagay mo dun yung tsaka na yun. So that's basically 1 minus 1 minus x quantity. So that's x. Therefore, a cube of x is just x. Nasundan nyo? Ini-illustrate ko lang yung ano. Ano masasabi nyo sa a cube this time? Sino siya? Sinong function yan? Sino yung function yung f of x equals x? May tawag kayo dun eh. It is called as the identity function. Diba? It's the identity function of s where yung s dito yung r without zeta 1. So yung a cube happens to be the identity. Ay, pwede pala yun, sir, no? Ang isang power ng isang element eventually equals identity. Yes, in group theory, that's a special occasion. Ito yan. Tingnan nyo ha. Let G be a group, and let's say its identity is the element E. Okay? And let A be an element of G. If eventually yung A to the N bumalik sa identity, naging identity, kagaya na nangyari sa previous example, after 3 iterations, bumalik ka sa identity, no? Yan. The smallest positive integer n where this will happen, sabihin kung kailan babalik si A to the n sa E for the first time sa identity, you call that n as the order of the element A. Just like in the previous example, anong order ng A? The order of this function A as an element of a group is 3. Kasi it gets back to the identity after 3 multiplications to itself. Okay? 3 factors of itself. And that happens for the first time when n is 3. Yung pinakamaliit na n, so that A to the n is E, is called as the order of an element. Iba yung order of a set, ha? Yung order of the set of a set is just the number of elements. Yun yung order of a group. Pero pag order of an element, ibang meaning nun. Ang meaning nun is the smallest n so that A to the n is the identity. Now, it can happen that A to the n, halimbawa, pag real number under multiplication, let's say 2 to the power of n, babalik ba sa 1 yung 2 to the n kahit na anong laki ng n? Diba? 2 times 2 times 2 times 2 times 2. Will you ever get back to 1? Hindi, di ba? Kung hindi mangyayari yun, if A to the n is not E for any positive integer n, we will simply say that A has an infinite order. Okay? Yun yung term na ginagamit natin. Kung with us if there are no confusions in notations, we will use this symbol to refer to the order of A. Hindi ito absolute value, ha. Although if you are in calculus, maybe you are using this symbol to refer to the absolute value. Remember, A here may not be a real number at all. So this does not mean absolute value. In abstract algebra, whenever you see the symbol, it is the order of the element A in a group. Okay? It's not the absolute value. In any group, the only element with order 1 is of course the identity. Kasi pag ang A to the 1 ay E, di ba? That means A is the identity. Ayan, narinig ko na yung MS Teams. I think nag-activate na yung assignment, but you don't have to look at it muna, no? Tapusin muna natin yung slides na ito bago natin buksan yung assignment. Mamaya papakita ko sa inyo. Okay? All right. Halimbawa, in the additive group of real numbers, when I say additive group of real numbers, ang operation ay addition. Alam nyo, lahat ng non-zero element ay may infinite order. Kasi halimbawa, si 1. Pag inad mo siya ng inad, ang exponent natin dito, kakaiba, hindi natin ginagamit ang exponential notation. Remember, yung exponents ginagamit lang natin for multiplicative groups. Pero ang meaning natin ng A to the n in the context of addition ay repeated addition kasi ang operation natin dito ay addition. Halimbawa, when you look at the element 1, okay? Pag inulit mo si A sa sarili niya, i-add mo ng i-add yan, babalik ka ba sa 0? Will this ever get back to 0? Magiging 0 ba? Eventually, magiging 0? No, di ba? Ang n copies of A will never, ang sum ng n copies of A will never be 0 whenever A is not 0. Yun yung sinasabi nito. Okay? The only time ang element ay may finite order kapag siya yung 0. In fact, ang order ng 0 dito ay 1 kasi siya yung identity. Kahit na gaano kaliit yung A na yan, let's say 0.01, i-add nyo si A yung 0.01 sa sarili niya ng paulit-ulit, palaki lang ng palaki, it will never be, the sum will never be equal to 0. Okay. Let's look at the complex numbers, the non-zero complex numbers under multiplication. Under multiplication, para wala ka namang problema, tatanggalin mo lang yung 0, di ba? Okay. Yung complex number na I, alam niyo yung complex number na I? Okay, alam niyo yung complex number na I? Sometimes sinusulat niyo yun ng ganun, di ba? Square root of negative 1, right? Kasi ang truth is, yung I times I, or yung I squared, is negative 1. Diba? Ang I cube is I squared times I, that's negative 1 times I, that's minus I. Ang I to the fourth, I cube times I, ang I cube is minus I times I, minus I squared, minus of minus 1. Aha, 1. Identity to. Diba? So, nakita nyo, yung fourth power ng I, ay ano? Yung fourth power ng I, bumalik na sa identity for the first time. So, what is the order of I in the group of non-zero complex numbers under multiplication? What's the order? Chat box. Anong order ng I? Very good for. O, ano namang order ng 2i? Check nyo nga yung 2i. 2i squared. Di ba? Negative 4 to. 2i cubed. Minus 8i. 2i to the fourth. 16. Ano kaya order ng 2i? Yung 2i ba babalik sa 1? Palagay nyo. Will this be ever equal to 1? Will a power of 2i be ever equal to 1? Never. Yes. Pag never, anong order? Infinite. Very good. You can write the word infinite or sometimes you can use the symbol infinity if you wish. Okay? Sabihin lang infinity, it will never ever, none of its positive powers will ever go back to the identity. Okay. Yan. Another example. Calculate the order of each element in Z sub 6 under addition modulo 6. Naku, paano to? Pag ano, syempre 0 element, lagyan natin dito, element order. Sige, summarize natin in a table. 6 lang naman yan. 0, 1, 2, 3, 4, 5, di ba? Z sub 6. Syempre, ang 0, order 1. Di ba? Order 1. Kasi in any group, ang order na identity ay 1. Kasi it needs 1 copy para maging identity. Now, how many copies of 1 do you need in order to get back to 0 for the first time? What's the order of 1? 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 0. Kasi modulo 6. How many ones did you need in order to get back to 0? Very good, 6. What is now the order of 2? How many copies of 2 do you need? At least. in order to get back to 0? Very good. The answer is 3. You need 3 copies of 2. How many copies of 3 do you need? This time it's a 2. Ayan, nakukuha niyo na yung vibe, na. What's the order of 4? How many 4? 4 plus 4, ilan na to? Walang 8, ha? 2 ito. Plus 4, tsaka ka magsi-0. Di ba? How many copies of 4s at least? How many 4s do we need? Very good, 3. Alright. How many 5s do we need in order to get back to 0 for the first time? Sige nga. 5 plus 5. Oh my gosh. What's 5 plus 5? 2 on your hand. So you need 5 plus 5 is 4. Plus 5, that's a 3. Plus 5, that's a... Ay, ang hirap naman. That's a 2. Plus 5, that's a 1. Plus 5, 6. How many? 6. Ay, oh my gosh. Alright. Naintindihan yung multiplicative order tsaka additive order. Magkaiba yung order, syempre. Pag addition, syempre repeated addition. Pag multiplication, repeated multiplication. Kaya you have to know in context, ano bang operation yung tinutukoy niyo, sir? Addition or multiplication? Naintindihan ba? So at this point, masasagutan na ninyo yung quiz number 1 because we got everything we need in order to answer quiz number 1. Sige. Ang susunod na lessons na natin ay tungkol sa subgroups, but I don't want to start yet. Ang gusto ko, kaya ako natapos ng 11 o'clock sa lecture, to give you time to somehow review and check the the quiz, no? Para kung ngayon nyo gagawin na yung quiz, di at least meron pa kayong 1 hour. Hindi nyo pwede sabihin hindi ko kayo binigyan ng time, okay? Matatapos yung quiz, ang pinakahuling oras para matapos nyo yung quiz ay 11 p.m. ng gabi. Okay, magsasara na yun ng beyond 11 p.m. Kaya you have to open it before 11 p.m. Okay? Meron ba kayong tanong? I'm going to stop the recording now.